Welcome to another day of school. Today we took from our daily ticker our card that had 71%. We're not using the percent because that's when it was out of 100. We're just using the 71 because that's how many days we have left of school. And the denominator, it depends what we want to do. We could say how many days we have left of school, how many days since our 100th day party. We can do all sorts of things. But for right now, we've kind of been doing out of the whole school year. And so whenever you have a word problem and it says something like 71, what percent of the school year do we have left if we have 71 days? Well, the numerator is 71 days left. And whenever you hear the word out of, it means the denominator, or like per means out of in percent. So what do we want the bottom to be? I'm going to say the school year. Now, the school year is represented as how many days of school is a whole school year cut up into. That's what the denominator is, what the whole is cut up into. And it is cut up into 180 days. Now, we know that this is a division problem from our previous experience here on Calendar Math, and we know that I can convert a fraction. All fractions can be converted into decimals, which then can be converted into percents. So I want to know what percent is 71 out of 180. Now I can estimate my solutions. Is it almost nothing, almost a half, or almost a whole? Well, if I cut 180 into half, I get 90. Well, 71 is closer to 90 than it is 0, so we can estimate that this is almost a half, or 50%. Correct? So we'll keep this in our mind before we even start solving it. This is what we can, sometimes when I was in school, my teacher said, oh, if you're not sure if you got the answer, do it twice. Well, if I did it twice and I got it wrong, did the same thing wrong, then I'm going to have the wrong answer. So I like to estimate all of my solutions so I have something to compare it to. So once I'm done here, I should have a percent that is almost or around 1/2 or 50%. Does that make sense? I hope so. If not, during our Zoom session today, ask me about that. Now, the other thing I like to do is, because these numbers are so big, I like to simplify before I start dividing all these big numbers. But we know 71 is prime. And if it being prime, I only have 71 and 1 as its factors, which I can't divide 180. So 71 180th is already in its simplest form. So let's go ahead and convert this into a decimal. And the way I do that is I read it from top to bottom as a division problem. Can you see the division sign? See the line right here and the line right here, and these dots each represent. Can you also see that this is the same thing as percent? See the correlation of the signs? Pretty cool, huh? So I'm going to divide. I'm going to divide it like this. 71 divided by 180. Now, in past, because we cut up our whole party into 100, I could just write 71 out of 100 was 71/100ths. But because it is 180, it's not really neat like this, because this is tenths place value and this is hundredths place value. I could just put the decimal point, but I can't do that for here because we don't have 180ths place value. So what I want to do is I want to cut 71 up into 100 pieces. And the way I do that is I add my decimal point, I cut up into tenths and hundredths. And by putting that decimal point and now going to parts of a number, I can cut it up into 10 pieces and then 100 pieces. And that's how you can cut up any number when you're dividing fractions to find percents. You can cut it up into a perfect. Now I'm back to the way we were for our first 100 days of school, that the answer will be able to be converted perfectly into percent. So here we go. I'll get rid of this so it's not confusing. But this and this are congruent. They mean the same thing, just written a different way. So what I do is I first bring up my decimal point. Now I know it looks like I'm bringing up the decimal point, but really what I'm doing is I'm just maintaining my place values. So the 1 in the 1's place value, my answer will still be in the 1 or the whole place value. My 77 is in the 10's place value, so my place up here is going to be in the 10's place value. And this is the tenths. My answer here will be the tenths. Here's hundredths. Here's my 100. If I didn't put my decimal point here, I would be moving my place value. So you want to make sure that your decimal point that's in the dividend is the same place as the quotient. All right, here we go. Now let's just slide over. I just like to take it one at a time. Make life easy. Just do one at a time. So I'm going to slide over. How many times does 180 go into 7? That's obvious. It's none. How many? Now I continue sliding over. How many times does 100 go into 71? That also is none. Now, how many times does 180 go into 710? Well, a lot of times what kids will do is they will multiply 180 times 1, 180 times 2, 3, 4, 5, 6, 7, 8, 9, 10, and then they'll have all these answers, and then they will compare which number will go in here that's under as closest to 710 without going over. But that takes so much time. Use what you've learned on front-end estimation to get a ballpark. Either you'll get it or you'll be off just by 1, and it makes it much simpler that you only have to multiply this by 2 digits in order to find the answer. And so when I front-end estimate 710, I know, because the number next to the 7 is not 5 or higher, it rounds to, or is front-end estimated to, 700. And when 180 is front-end estimated, it rounds to 200. So now you can either do this on a piece of paper or in your head. I mentally do it, and I can see that I have 2 zeros here, or it's in the 200s place value, and here I have 2 zeros, or the dividend is in the 200s place value. Well, I know 100 divided by 100 is 1, so I just cancel them out. And now I know 2 goes into 7 3 times with a little bit left over. But then again, 180 was a little bit less than 200. So it'll be very interesting how this works out. But I know 3 is a really good ballpark to start with. So I multiply 180 times 3. I get 3, 4, 5, 540. Well, let's see if we did it. 540. Subtract. I get 7, and I get 1. Oh, look at that, 170. Now, what I do is I look at the number here. If the number here is smaller than the divisor, I know I can't keep dividing 180. If this was 180, I would know I could add 1 more. But because it's less than 100, 180 cannot go into 7, so I know 3 was the right number. And so now 170 needs some help, so the next place value comes down saying, I'm coming to help you, buddy. Now, how many times does 180 go into 1,700? Well, I do the same thing. I just estimate my solution, and I know this is closest to 2,000. And I know this front end estimating is closest to 200. Well, I'm going to cancel out or divide by 100 on my divisor and on my dividend. Now, look how neat that is. I know 2 goes into 20 perfectly even 10 times. Well, it can't be 10, so I know it's going to be 9. So 9 times 0 is 0. 9 times 8 is 72. And 9 times 1 is 9, plus 7 is 16. And there we go. So look at that, 39. So my quotient is 39. Now remember what I told you at the very beginning. Before we even started this, I said in your mind, do an estimation for all fractions. Is it almost nothing? Is it almost half? Or is it almost whole? Well, we knew it was almost half. Now look at this. 39 is converted because 39 hundredths is the same thing as 39%, because percent means out of 100. So is 39% almost half or 50%? Yes, it is. So I think we have ourselves a winner. So that means we have 39% left of the school year.